Morning, my dear students. Today we are discussing about refractive media of the eye. So what is the reflection? What is the normal range of the visible normal range? Now we discuss. So what is the refractory media of the eye? So first to before discuss reflection media, we discuss about the visible light. So visible light. So the visible light is a wavelength range from the visible light wavelength. So visible light wavelength from 400 to 700 nanometers range. So in between of this range, we detect a particular thing. We detect a particular length. In case of decreasing of the 400, increasing of the 700, there is no chance for the identification of the particular thing. So what is the normal range of the eye visible light? So visible light is wavelength is a 400 to 700 nanometers. Only can exit the photoreceptors. In here only can exit the photoreceptors. Infrarays cannot excite. In here infrarays cannot excite. So felt only as the heat ultraviolet rays filtered out by the lens of the eye. So this is the introduction about the visible light. What is the normal range? 400 to 700 nanometers. So what is the meaning of the refraction? So refraction, it is a bending of light rays when they travel bending of a light rays. So when they travel in two transparent media with the two different refractive index provided the travel by the angulated reference. Is known as a refraction. Refraction means it is the bending. It is the bending of light. Bending of light means, for example, here light is transferred here and bending this one. So bending of light rays. So when they travel in two transparents. Two transparents means fluids. So two transparent fluid media with two refractive indices. Provide that they travel a angulated interference. Provide that they travel at angulated interface. So provide angulator interface is known as refraction. So what is the refractive index? Ri, refractive index. So refractive index of the medium. So what is the refractive index of the medium? So it is Ri is equal to formula. Ri is equal velocity of light in air. Velocity of light in air divided by velocity of light that medium. Velocity of light in that medium. So this is a refractive index. So for example, so what is the cornea refractive index? Ri of cornea is 1.38. So 1.38, it means 1.38, it means is equal to velocity of light in air divided by velocity of light in cornea is equal to, both are is equal to 1.38. So what is the cornea? Cornea refractive index. How to detect? Velocity of the light in air divided by velocity of light in cornea is equal to 1.38. So that is the formula of the refractive index, refractive medium. So in here identify the parallel rays coming from the distance. So how to detect this particular refractive index? So in here this one is a diagram for the detection of the refractive index. So this is the, it one is a focal point. This is called as a focal length from here to here. Focal length. So in here parallel rays from distance is a greater than 6 meters. What is the distance? Greater than 6 meters. So the parallel rays coming from distance 6 meter will bend toward edge of the convex lens. This one is the lens, edge of the convex lens. So write down parallel rays coming from distance is the 6 meters. So will bend towards so convex lens, we bend towards edge of the convex lens. In the cornea of the lens, the rays will be passed single point to focal. This rays is passed to single point to focal. So the focal length is the distance between central part of the lens to the focal point. Is known as a focal length. So this is about the identification of the refractive medium and refractive index. So this one is about the refraction media of the eye. So now we discuss about the one more topic is the intraocular fluid and intraocular pressure. So what is the intraocular fluid? Now we discuss about the intraocular fluid. Intraocular fluid is known as a aqueous humor. It is also called as a aqueous humor. So what is the intraocular fluid? It is also called as a aqueous humor. What is the aqueous humor? It is a clear and colorless watery fluid filling in the chamber of the, it is filling a water fluid filling in the chamber and posterior chamber of the eyeball. So what is the intraocular fluid? It is a clear substance, colorless water fluid filling in the posterior chamber of the eyeball is known as a aqueous humor or intraocular fluid. So what is the volume of the intraocular fluid? 0.3 ml. 0.31 ml is the intraocular fluid. In the 0.3 ml is divided into two parts. One is the anterior, these are filling in the anterior chamber as well as the posterior chamber. So the anterior chamber is the anterior chamber and posterior chamber. The anterior chamber, it consisting the 0.25 ml and 0.6 ml is presented in the posterior chamber. And what is this is about the volume of the intraocular fluid. And the next one is refractive index. What is the refractive index of the intraocular fluid or aqueous humor? This one is a 0.336. 0.336 is the refractive index of the intraocular fluid or aqueous humor. So how to detect it? So by the formula is there, by using of this one formula is detected the refractive index. So this is about the refractive index of the intraocular fluid. And the next one is what is the density? What is the density of the intraocular fluid? The density of the intraocular fluid is a 1.0252, 1.040. This value is greater than the water, though the water density is the less compared than the intraocular fluid. So this is about the density of the intraocular fluid. And what is the pH of the intraocular fluid or aqueous humor? 7.2. 7.2 is the intraocular fluid pH. And what is the rate of formation? Rate of formation, how much are produced from the eye intraocular fluid? So formation is a 0.3 3 mu L per minute, 0.3 mu microliters per minute it produced from the human eye. And what is the composition of the intraocular fluid? Intraocular fluid is composed by the mainly two parts. So one is the water and solids. So water is the 99.9% water, 0.1% is the solids. 0.1% is solids. So in the solids, what are the different components are present in the solids? So first one is the proteins. So proteins, and the second one is the amino acids. Proteins, amino acids. And the next one, colloidal constants, non-colloidal constants. And the next one is a glucose, urea, lactate, sodium, potassium, and the next sodium, potassium, and chlorides. The next one, carbohydrates, and as well as the oxygen in dissolved in state, oxygen, and etc. This is the composition of the intraocular fluid. So the intraocular fluid is divided into, depends upon the concentration, divided into two types. One is composition, depends upon the composition. The intraocular fluid is classified into two types. So one is the high concentration and low concentration of intraocular fluid. High concentration of intraocular fluid means it containing the ascorbate, pyruvate, and lactate. It containing the ascorbate, pyruvate, and lactate. In case low concentration means proteins, urea, and glucose. So this is a classification of the intraocular fluid, depends upon the composition. So in this composition, what is the functions of the intraocular fluid? So what is the functions? So what is the functions of the intraocular fluid? So number one function is to maintain the proper intraocular pressure. Maintain the proper intraocular pressure, and play a important metabolic role by providing a nutrients and removing the metabolites from the vascular cornea and lens. So in the lens and cornea, removing of the metabolites, and as well as the removing of the metabolites, and as well as the provide a nutrients to the lens and cornea. So the next one is maintain the optical transparency. Maintain the optical transparency. transparency. So in case of there is no chance for the any disturbance in the optical transparency, we cannot detect the items, and you cannot detect the surrounding area. So that is the importance of the optical transparency. That one is maintained by the intraocular fluid only. Intraocular fluid. Then it act as a limp in the eyeball. It act as a lymphatic system in eyeball. In the eyeball, act as a lymph system by the intraocular fluid. And the next one, it one is a production of the aqueous humor. The aqueous derived from the plasma within the capillary network. The normal aqueous production in rate is 2.3 ml per minute. That's one is we already discussed about before class. So the next one, the system of the maintain the act as a semi permeable membrane. Semi permeable membrane. The next one, then this is the importance of the functions and importance of the intraocular fluid. So the intraocular fluid, the next one, the intraocular fluid is depends upon the human body, depends upon the age, depends upon the sex also. It's a changes in the particular functions and changes in the composition also. So this is about the intraocular fluid. So now we discuss about the intraocular pressure. Next one, we discuss about the intraocular pressure, IOP. So intraocular pressure is excreted by the intraocular contents of the coats of the eyeball. So this one is pressure exerted by the intraocular contents on the coats of the eyeball. So the next one, what is the normal IOP? Intraocular pressure. What is the normal intraocular pressure? So normal intraocular pressure is a 10 to 21 mm for hg. 10 to 21 for hg. So the next one, the IOP essentially maintained by the dynamic equilibrium between the outflow of the aqueous humor. So what is the importance of the intraocular pressure? The intraocular pressure is maintained the dynamic equilibrium. It maintains the dynamic equilibrium between the formation and outflow of the aqueous humor. Humor means, what is the aqueous humor? Aqueous humor means intraocular fluid. The intraocular fluid formation and intraocular fluid from inside to outside flowing, it depends upon the intraocular pressure. So what are the factors are influencing the IOP? Factors influencing IOP. So intraocular pressure is influenced by the factors. So it is the two types of factors. One is the local factors, and the second one is the general factors. So what are their local factors and what are their general factors? So local factors and general factors. So now we discuss about the first local factors. So local factors are the first one is the rate of aqueous formation. Rate of aqueous formation. Second one is resistance to aqueous outflow. Aqueous outflow. And the next one is increase the venous pressure. Increase the venous pressure. And the next one, dilation of the pupil. Dilation of pupil. This one is the local factors. So what is the general factors? General factors. So what are the general factors? General factors is the first one is the age, second one is the sex, and the next one posterior variation, postal variation, and postal variation, effects of drug, effects of drug, and refractive errors, refractive errors, and the next one is the refractive errors and effect on the general anesthesia, effect effect of on the general anesthesia. General anesthesia means the loss of sensation. Total body, the total body loss of sensation is known as the general anesthesia. And then osmotic pressure, osmotic pressure, and the blood pressure, etc. These are all are the general factors of the IOP. So the IOP, how to measure the IOP? Measurement of the IOP. What is the measurement? How to measure the IOP? So by the two methods, one is the manometry method. Manometry method. Second one is the tonometry method. Manometry method and tonometry methods. Manometry method and tonometry methods both are the detect the IOP in our body. This is about the introduction and introduction of the IOP, introduction of the intraocular fluid and refractive index. If you have any doubts, tomorrow we will discuss.